If you turn on cable TV,
add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't if you turn on cable TV,
Add social media.
Here's what's happening at this moment.
shut up, moron. Don't
Hello? Hello?
if you turn on cable TV,
Add social
No.
media.
Here's what's happening at this moment.
shut up, moron. Don't
Okay. All right, hang on. Hello, hello, test. Okay, sound seems all right. Let me quickly check and get confirmation of that. I've got all this other stuff loaded on this machine. So hang on a second.
Three times richer than.
Okay, do we have a good sound? I'm echoing. Damn. All right. Hang on. Still an echo? Okay, let's see. Okay. That's fine. Somehow I'm picking up both the webcam and the headset here, so hang on a second. Yeah, playback monitor audio. I don't have that activated, so hang on. Shut off there. I wanted to use the headphones because it's okay now, much better. All right, okay, let's get rid of that then, no echo. All right, now hopefully the sound will be all right because I'll be facing the board here quite a bit. All right, so now we're, okay, so now I don't have, hang on a second. I'm not getting a refresh on my monitor. No picture exactly. Okay, so hang on. Oh, there we go. Okay. All right. All right. That should do it. Okay, so that should do it. Echo? Oh, we're good. Okay. Here's where we're at. So, what we're going to discuss. Let's see how I'm going to do this. All right. No echo with the headset. Hang on, so let's get rid of that. Let me see if I can delete that. Just get rid of it. Okay, we'll just take it out. Yeah, I know. Okay. Okay, so do we have sound? Sound okay? All right, okay, good deal. Here's what we're going to go for. Voyager 2 and the magnetic dielectric bubble around our solar system confirms the electric universe model. And not only does it do that, it confirms a number of other things that I just won't go into, but I've got a really good idea here based on something that Tesla came up with. So I'll describe what Tesla did, and then I'll show you what the fourth state of water is, and show you what the idea is, right? Okay, so Tesla, if you go and get his Colorado Springs journal from like 18 something, onwards, he has a whole series of experiments around the idea that it should be possible to basically create a current that you can tap off of based on the difference between Earth and the upper atmosphere. And so we're going to draw us a little hill like Tesla had, and up here is our upper atmosphere, and the idea is that this is negatively charged, which we will indicate as these little dashes, and they're not to indicate negatively charged ions so much as just a general negatively charged state in the upper atmosphere. And the idea being that this down here is positively charged, and you can ground out to this and tap off. And so the idea is that you would build yourself a little tower. Let's build a little tower. And they built one out of wood, and within that tower you would suspend basically a chunk of wire that came down into the ground and would reach up high enough that it would attract all of the little negative charge, and you would get the difference between the two. And in this sense, it's sort of like the heat pump in a house, right, where you pump the heat in essence down into the aquifer in the summer and extract heat out of the ground in general in the winter, just based on the difference between the ground temperature and the air temperature. Okay, so this is what Tesla did, and this was in Colorado Springs, and it worked. The problem is that the the current that actually flowed down his wire, if we want to think of it that way, was infinitesimally small, okay? So it was kind of like a Stirling engine's version in free energy. Stirling engine, in case you don't know what it is, it's a hot air engine. And it works, it'll run forever, the hot air is relatively free, it's another form of a heat pump, but you can't get enough torque off of it to make any real use out of it, right? And so this is what he had here. The current flowed, but it was so infinitesimal relative to the amount of the structure and so on, and it varied considerably based on the atmospheric conditions. And so in that sense, it was a successful experiment. It proved that there was a constant dielectric difference between the upper atmosphere, even insofar as he could reach with a 100-foot tower, and something buried down into the ground. And they buried it down into, I think it was like 9 feet, and it went down to a local aquifer. And they figured to be able to, quite easily ground out and draw the current through and be able to tap off of it. And the idea is that you'd have a little tap here that would take the stuff down to your little house, sitting over here in a lopsided way on the hillside, right? And so you would be able to get free energy, so to speak, once you had the, C60 is damn fine. Once you had the capital expenditure and the tower and so forth. Only, as I say, it didn't work. And bear in mind, Tesla was after voltage. He really liked voltage and amperage. He was into heavy-duty amounts of electricity. Okay, so now something else to consider. It didn't work for him when he built it, and they tried the experiment several times. Under the conditions in which he built it, okay? But the thinking was sound, it just was not feasible or practical enough to make it worthwhile. His thinking was that you might have to go miles up into the atmosphere to be able to get enough current to have what we now know of as the tether effect of taking the tether up in the atmosphere. Okay, so here's something that everybody should understand. 1 volt of electricity can be thought of as 1 foot of copper wire of a certain size being sliced through 1,000,000 lines of magnetic force. Okay, as it slices through those 1,000,000 lines of magnetic force, which might be packed into a short distance, it'll create 1 volt of electricity. Not that you're going to be able to do anything with it, whipping a piece of copper around. It just isn't going to work. But that's basically what we do when we spin copper wire on coils around a ferromagnetic or around a ferrous rod inside of a magnetic field. Okay, so is that we're slicing these lines of electricity. And so this was sort of a tether approach where if you had a tether of an appropriately conductive substance that was strong enough, and you could take that tether out into the other atmosphere, you could create vast quantities of electricity. And this is exactly why we'll never have the elevators into space, okay? The reason we won't have them is because there will still be there's a lag between the actual rotation of the physical Earth and the magnetic field of the Earth as they both move. Thus, anything that sticks up far enough off of the Earth to be able to reach high enough up into the upper atmosphere is going to slice these magnetic lines and create voltage, vast quantities of voltage that will want to go down that wire. Now, maybe we can engineer these elevators up into space out of a material with the design that they'll do exactly that and produce vast quantities of electricity to not only power themselves but to power other things down here on Earth. And you could even do it with carbon. You could certainly do that if you had carbon nanotubes constructed in an appropriate way. And when we've got 3D printers that can start printing in carbon bonds, then we're golden. Then we'll be able to build all this stuff and not have to worry about it. Okay, so anyway though, this right now is a practical sort of thing because conditions have now changed. Because of what Voyager has brought back to us in the way of information about the electrical atmosphere in which we live, if we want to phrase it that way, we can now understand that what was defeating Tesla on this idea was not any inherent limitation within his idea, or even really the inherent limitations within his technology, that is to say the quality of copper, the shielding on it, the tower, and so on. That wasn't a defeating, that defeated him, or so he thought, but that really was not the issue. Turns out that there's this other element that's going on here, okay? And the aspect of that is that Tesla was under the assumption that within the Earth as a whole, this positive dominance was ubiquitous, and it's, or more or less, given magnetic anomalies and all that kind of stuff. And it's not. He was and Marconi were of the opinion that there were subtle differences, and you could use that with the radio, which they did, and they perfected devices that did that sort of thing. But his basic understanding was that there wasn't enough variance in the positive charge of the Earth to worry about it. And this was due to a misunderstanding of certain conditions relative to the Schumann resonance. Okay, the Schumann resonance frequently is misunderstood. There's a bunch of them. The Schumann resonance has to do with the frequency between the ionosphere and the Earth. If this distance here changes, the Schumann resonances change because there's different frequencies that you can pump electricity in. Now, I didn't want to get diverted into that, but in any event, so Tesla was under the understanding that there was no place on Earth that it was significantly different that he could go to obtain this positive charge. He knew that in the upper atmosphere there was vast quantities of what he thought of as distorted dielectric field of that could produce what we think of as the negative part of voltage, and he knew that that was the case everywhere around the planet, just by the nature of air and the rarefication and so on. But he was under the impression that basically within a very small delta, which was meaningless within the overall potential that he was after, there was no place on Earth he could go to increase this right here. And that's not true. And we now know that that's not true. We now know why that's not true. And we also know that it will be perpetual. Okay, and here's the deal. Because of what Voyager 2 has brought back in the way of an understanding of the nature of the field we're going through, we now know that our sun, let me get us red. Okay, so our sun is here. It's got a corona all around it. That corona is hot out here and cold near the sun itself, right? The sun is actually colder, far colder than any part of the corona. This makes no sense if it was nuclear, so it's not nuclear. It does make sense if it's a plasma arc, like a TIG, a tungsten ionized gas welder. Tungsten ionized gas welder is an insulated rod up here with a bit of tungsten that comes on out, that you put a ball onto by shaping it a particular way. There's gas that's blown out around there. The gas comes on out here, and the gas, because of an electrical charge, ignites and becomes very hot, but the tungsten itself is very cold. As everybody who's ever done any TIG welding will tell you, once you touch that cold tip to the actual product you're working on, it's shot. It instantly cools the product down and it fuses. And so what we're actually dealing with in our sun is an ionized gas ball. Now, it's a plasma generating gas ball. This plasma generating gas ball also generates what we can think of as like a basic further disturbance. Let's just say that we're moving through space that way. The planets are back here in spiral orbits being drugged behind the sun, basically in a big cone, and there's a dielectric distortion of the field out here, and they call this the bow wave of the heliosphere, and they think of this thing here as the heliopause. That is, scientists do, right? Academics. Think of this boundary layer that Voyager is now trapped in as the heliopause, the space between our solar system and what amounts to free and open interstellar space. And they're thinking that the vacuum that is created by our sun's moving, which exists back here in the planets, also exists out here, which is not the case. And our sun is moving through a media that, because of the way that it moves through the media, it it generates the dielectric potential that causes the gas around our sun to erupt very much like the gas in a TIG torch. Okay, and so that's why we have this particular structure. But what we need to note now is that this banding here relative to where Earth is, let's just say that that's us there, that this banding here creates a particular kind of potential that exists now on our planet and always will exist, and we can take advantage of it relative to Tesla's idea. And I was looking at the patent form and all of the rigmarole and so on, and I said, screw it. And I'll explain why. I've got a potential test site, I can build this, but because it's just basically me doing it, it's going to take me a lot of years to build something that's more than simply a proof of concept, okay? And so the thing was that that here's the approach to this. We have at our disposal right now what's known as the fourth state of water. Okay, so we have water, we have ice, we have steam, and then there's another state of water that is actually more in line with the actual understanding of what water is. Okay, and it is that fourth state of water is affected by which of these physical states are manifesting within that water at any given moment, but that fourth state is independent of these and outside of being modified by these states exist continually. Okay, so we can call that fourth state whatever we want, but I'll put it down here as its electric state, okay? Because water has an electric body. So here's what we actually have on Earth. So here's the hill up in Colorado that Tesla worked on, and we're going to just go chop out most of the country. And here is a hill near me that comes on out, and it's going to go down like that, and that's this bluff, and then it's going to go out to a beach. Now, that beach here is influenced by the ocean, and here's the ocean from that point on like that. And this is marks the edge of the continental shelf. Now, of course, there's a great distance between Colorado and the continental shelf. So I'm not proposing that we do anything at all like this. I'm just showing why it didn't work. It turns out that the positive variance of Earth is gigantic at those points where the ocean meets the land. And this is true all along this particular boundary down here, where there's actually land underneath that water. And here we have this, let's just say that there's three positive charges per clump, okay? And that's our official designation. There's 3 positive charges per clump in the Earth. Well, for that same amount of material out in here, out in the water, there's up to there's between 20 and 40 times more charge per clump. Okay, so instead of 3, we'd have lots and lots and lots and lots and lots and lots and lots of these positive charges out here in the water, such that we had a magnification here, a delta of some vast number. This will vary considerably based on the time of year, and it'll vary considerably based on the local weather conditions. However, certain things are true. The further you go out to ocean, into the ocean, along this border down here, the more consistent the positive charge per clump, per area, is. And that consistency stays there longer. It's more flexible and floats around a lot more out here. So sometimes here it's very close to the 3 in land, right? In regular land. But out here it'll be always consistently, as soon as you start crossing over the edge of the continental shelf, and actually as soon as you get below this thing called the thermocline, which is a temperature gradient within the ocean, as soon as you get out there far enough where you can get at it, your positive charge per clump stays pretty high, and from that point on it would be actually practical. And so the idea is that instead of doing this here and grounding out there, we would drag out a big giant chunk of copper, and actually you'd have to have a ceramic fitting on the end of it, just so that it doesn't corrode. And it would come on back and it would join on up here to our tower. And so we would have a massive delta between the amount of field disturbances up here, potentiality, the capacitance that's available in that field, the capacity of electricity that's being moved around, as well as the grounding capability down here. And so you could do this on the coast. So we could just eliminate the idea that we've got the country between us and just say that this was mounted somewhere on the coast near me. Now, the reason I can't do it is because even though I found a spot, see, there's a couple of things you have to think about. In doing this, you're going to be dragging a piece of cable through and up over a beach. In Washington State, all the beaches are public property and stuff, except in rare situations. And so people could walk across it and potentially get hurt or damage your equipment. So there's all the different kinds of considerations to actually doing this. But it's very feasible, and a proof of concept could be done fairly quickly, fairly easily, and then, you know, temporarily, so that you could put it in place and then disassemble it, so that thereafter, if you needed to actually try and pursue it as a working model for generation of electricity, you could then go through all the rigmarole of the permitting process and figure out what you're going to have to do to protect it and the humans that are and animals that are trucking around near it. So Tesla proved it. He proved that it was practical, but it was impractical to the level of device that they had at the time. Had he tried to do this with his 100-foot tower in order to charge a cell phone, would have worked beautifully, because there isn't much in the way of microamperage that needs to be drawn off. But in terms of doing anything practical in his day and age, it just didn't work. This way, though, it probably would. And then we also have a further variant on it. Okay, we have two other ways of magnifying this effect now that we know that we live in this a particular kind of a sea of potential energy continually, and that we need to just think about it differently in order to achieve a practical use of it, a more practical use of it. And so there's two aspects of this that I was going to say that we can perform that will cause this to become very eminently practical. And these were parts that I was going to patent, but they're so obvious, it's like, you know, why bother? Okay, so one way to do it is that we must increase, okay, so in order for this to work at its maximum potential, it's necessary that we begin with a chaotic, distributed, let's call it distributed, pickup on and discharge on both ends. So instead of this being a cable up here, it's going to be like a bundle of wires that come on out at slightly varying lengths that all run down through a central kind of a insulating mass, okay? And so that that component right there increases our pickup level relative to this, and we also do it down in the ocean side. Only on the ocean side, we actually take our positive charge, our grounding lines, and we spread those out like feet out through the sand and do this, but they're not, so in the ocean side, it comes down to something like this as opposed to a clumping, and so that we get as much possible spread on these things as we can. Now, the reason to do this has to do with the fact that we're dealing with a field, and in order to pick this stuff up out of the field, we want to have as much of the field involved in this as is possible. This is obviously a very crude approach to this. Quite obviously, we'll be able to at some point figure out how to fold this whole thing into a small little box that you have sitting on your porch. But at the moment, we're doing something along these lines. And so anyway, so you do that, and then you do the other side on the ocean, and then there's a further thing that you do, and that is at the point that you have your tap right here, where you're going to take off your, let's call it household current, to run your house and charge your cell phone and run your toaster and all of that. At that point right there, what you do is you have a series of magnets. They'll have to be neodymium magnets. They'll have to be oddly numbered, I suspect, as opposed to evenly numbered, right? in terms of the number of these critters that you end up with. And so let's just say that we're going to have something like that, okay? And within the middle of this is our bundle of wiring that is going up and down. So we're looking at this at a cross section, sliced through, top down, and this is where our tap is, and we'll simply have an unshielded part of the cable there and an actual exit magnetically shielded right here and right there wire to take the household current off. And these are magnets, and the magnetic field that's going to be generated by these magnets is going to cause a coherence, a focusing, a lensing effect. It's going to be created by all of the magnetic fields from these disparate magnets that are held out a certain distance away from that wire and are of a certain Gaussian strength. And of course they're going to be radiating out a field out there, but we don't care. They can all be bounded by some magnetic shielding metal. And the idea is to get all of the electricity focused into some more coherence there at the point that we tap off. And there's our free energy device. It's not free because we're going to have to build a big bloody tower. The taller the better. We're going to have to run a lot of wire and stuff out into the water. We're going to have to engineer ceramic electrical pickups that won't corrode. We're also going to probably have to figure out how to keep barnacles and that kind of other benthic organisms from living on them. We're going to have to insulate the whole thing. We're going to need lots of copper and so on. But it would work. Okay, you could actually probably do something like this, running this line off to a pond over there in Colorado, because the water is going to be the same way everywhere. You can actually get this electrical difference in water in a glass if you let it stand, and if you had sensitive enough electrical pickups, you could actually pick up the fact that the water's got more of an electrical charge near the abounding area of the container and is in fact electrically negative in the middle. And we know that what I'm saying here is factual in terms of this relationship with the higher level of the positive grounding effect of electricity here, because we've all experienced it. Anybody who's ever been to the ocean goes there and goes, wow, that air smells good. And you think of it because there's no pollution and, a lot of wind and that kind of stuff, right? Frequently the ocean stinks. So let me tell you that is the case. But nonetheless, there's always this invigorating, embracing quality to it, and that's the negative ions as we think of it in an atomistic sense. The negative charges that are drawn here by the positive charges. So there's a converse to this that we need to pay attention to, and that is that over these areas here, out in the atmosphere, there's a lot more negative charges as well, because they're basically drawn here by this attraction, by this, and it really isn't that. I mean, there's no atoms, there's no movement there, but because you have the distortion of the field here at this level with positive, you're also distorting it with the negative. It can't be any other way. And it has to do with all of this other stuff at a deep level within magnetics. And hey, let me tell you, okay, so here, if you take nothing away from this, we're going to shut down here real quick because I got to get in and get some coffee. But if you take nothing away from this, go to, especially if you have a Kindle, I had to go through a whole lot of stuff to be able to read the bugger. But there's this guy's book that's really good on magnetism, lays it out, absolutely nails it, right? Nails it. He writes about magnetism at a level that Buckminster Fuller wrote about in Synergetics, okay, about physical matter and the nature of universe, and what do you call it, the vector equilibrium. Okay, so Buckminster Fuller wrote a fantastic book in Synergetics. Okay, this other guy wrote this other fantastic book, and I'm sorry, I can't think of its name at the moment, but his name is Ken Lee Wheeler. Wheeler. Ken Lee Wheeler. And he's got a YouTube channel. And his YouTube channel is under his, okay, so that's his secret identity. I'm not outing him. He used his real name on the book. The book can be bought on Amazon. He's got a bunch of books. You can buy his other books about other subjects, but there's got a great book about magnetism and electricity, okay? So you can go and see him. So I'm not doxing him or anything. This is actually his you know, I mean, he used his real name when he wrote the book. But his YouTube channel is under his superhero identity, okay? And that's Theoria Apophasis. Theoria Apophasis, okay? And he's like his superhero identity. He's a superhero translator of ancient Greek. I kid you not. And if we ever had the chance, I bet you he's got more tattoos than Joe Rogan. Okay, he's a really interesting guy. A lot of people won't be able to follow what he's saying because each and every one of the words he's using has to be crystal clear in your head in order to understand the conjunction that he's making by joining them that way. All right, so, and it's very deep stuff, and so a lot of people will just blow it off, but the guy is really smart, and if you can watch his YouTube stuff for free, or you can go and buy his books on Kindle. And the magnetism one is really cool. The magnetism one is going to allow us to do a lot of this sort of thing in terms of magnetic lensing, which will be very interesting as we go forward. So anyway, the guy's, like I say, he's a piece of work, let me tell you. You know, I mean, he's really smart, and but I don't know if he does like design or if he invents shit or if he's just interested in the fundamental science. My thing is I want to fly around in the little anti-gravity devices, right? So I have a practical bent. So I'm like the guy that wants to be able to go and park over a lake and have the bay doors open up on his anti-gravity device and drop a line and do a little fishing. So I don't know what what Ken's motivation is. Anyway, though, so check him out. It makes all of this kind of stuff makes sense, and you'll see why I got so excited about the confirmation of the electric universe. That, like, you know, that was the final confirmation in terms of that was what was needed to say that we I'm sure there are people that can misinterpret what the Voyager experiment has now proved and think of it as somehow a reinforcement of an atomistic view of universe. It is not. It is a confirmation of the field and electric nature of universe, which is fantastic because we can throw away a lot of this math, you know. Anyway, so I've got to go. I've got a lot of stuff going on, and I wanted to dump this out since I'd done the work on it and thought about it and figured it out and wrote it all up. But I'm not going to be able to build it. See, my problem is that I can't do this kind of stuff where we're at on the beach I'm at, because even as a proof of concept, because my beach is so flat that I would need literally miles of electrical cable. And I can just see the local county saying, "You want to do what?" You know, so, but I did find a place. If there were ever a group of people that had the money and wanted to pursue this, I know a place around here where property could be purchased that is freehold property, so unrestricted use, free access, and it's bounded by tribal land, and yet it still gives you access to the ocean. It actually has some waterfront. And so you could do this there. You could probably work out a deal with the tribe because of where this land is to keep people off of it. Literally pay the tribe to set up some kind of a barrier to keep people from wandering off of their property. And this, because it's so isolated, the idea that, I mean, you'd be dealing basically with, you know, bears and cougars and elk herds that might be wandering across this whole thing. So you'd be dealing more with wildlife than humans. So I know a place that it could be done. But, you know, I'm old, it's an hour north of me, I'm not inclined to do that. But if someone wants to, I could point them out where all this stuff is and work a deal with them. Anyway, that's where we're at as far as I'm concerned. This is released to the public domain. Thank everybody for stopping by to have a look. So I know, and this is unfortunately, you'll notice that I put number 1 in this. I'll change the little screen capture thing later on, so there's likely to be more of these as I go forward with thinking about Voyager 2 and the electric nature of the universe and warping fields. I think that's what I'm going to do next. I'm going to go get some coffee and think about how to warp fields. Bye, guys. Thanks a lot, and I'll see you later. Oh, and spread the word, all of the liking and the clicking and the bells and all of that kind of shit. Thanks.